In the last video I talked about some of the terms we had for lines and segments and also for arcs and circles. Alright, so now let's just talk about the types of angles. And again, I'm going to do the same thing, draw a diagram and then kind of show you, give you a definition. So central angles, right? So draw yourself a circle. Okay, and then put a center. That's the key, right? Central angles have the name center in it. Okay, and then put an arc there. I'm sorry, put an angle right there. Okay, and this right here, right? This is your central angle. Okay, and the key aspect is well, it's an angle. And the key aspect whose vertex is at the center of the circle, and whose sides are radii. Okay, so these sides must be radii for yourself. So if you have a diameter as a side, that doesn't make sense, right? You have to have the two radii. You can't have chords as sides, right? It must be a radius. Okay, that's your central angle. All right, not to be confused with inscribed angles. Okay, all right, I'm going to draw a circle, put the center on it. Okay, now notice it says inscribed and not central angle, so that I'm not going to worry about the center. Here's what I'm going to do. I'm going to instead, okay, right. And you know what? I even made this definition too long. I was a little redundant, and I think we can make this a better definition. If you look at it, how do I draw it? I just drew two chords, right? So an inscribed angle is an angle with two chords as sides. Okay, and the sides have to have a common endpoint. And I'll say it as its vertex. Okay, so really, just if you look at the two sides and their chords with a common point, right, common endpoint, then it's an inscribed angle. So this right here is the inscribed angle. Okay. So for both of these, I have what I think are awesome activities that we would have done in class, but unfortunately we don't really have that opportunity, right, with what's going on now. So I'm just gonna have to tell you what the properties are for these. Okay, and the key for central angles is that the measure of the central angle equals the measure of the intercepted arc. Okay? So whatever the measure, and I'm going to get my highlighter out for this. Hopefully the highlighter's still here. There's my highlighter. Okay? Okay. So if I trace my central angle, and notice I went past it, okay? Whatever the measure of that angle is the same as the measure of this arc right here. So if that angle is 80 degrees, then this arc would be 80 degrees, okay? If this angle is 70 degrees, that would be 70 degrees, okay? If we take a look at our inscribed angle, right, and you can see that that inscribed angle, right, they were pretty much the same size, but look, the arc was a lot bigger, and it makes sense it's a lot bigger because it has a lot more time. The angle has a lot more time to grow and grow and grow as it goes out there. Okay, so here's the relationship for those. Okay, so the measure of the inscribed angle equals half the measure of the intercepted arc. Okay? So if this angle was 70 degrees, that would be half of this. This would be 140. Right? And so actually it looks more like that angle 60 from what I have, so that looks like it's 120. And you see that makes sense. Like if that's 60 and I said that's 60, that doesn't make sense because this looks to be more than a right angle. So it just doesn't seem logical for yourself. Okay? And so you'll see that. Like if you accidentally make, you know, inscribed angles equal the arc that they intercept, it just won't look right. It won't make sense from what you have there with right angles as you do it. Okay? So let's do some examples here. Right, for ourselves. Well, I'm just looking ahead to see how many examples. Yep, plenty of examples. Okay. Right, and so I'll go through and do some here. Right, and then I'll post the rest of them. Okay, so I'm not going to do every single one. I'm going to have you guys finish this on your own. Okay. So find the missing measures in the given diagram. Okay, so I was kind of vague here about what measures to find. Okay, right. So what measure can I find? Well, if I take my highlighter out and I highlight my angle, right, and that's a central angle. It's always good to label that the central angle. Okay. If I look back to what we just said, central angles equal the measure of the intercepted arc. So that's a central angle. So the intercepted arc there, right, which is right here. There's the intercepted arc, and use your highlighter on this. Right, make your diagram messy. The measure of the angle of the arc AC. And notice I put that angle symbol there. This tells people that we're getting the angle and not the length of it, because if it's kind of ambiguous otherwise. So we put the angle symbol to tell us to give me degrees on it. So that's going to be 70 degrees there for that. Okay. If I added another point, let's say a point over here, okay, and I could actually find the measure of the arc angle for ATC. Okay. Okay. So the measure of the angle of this arc ATC, well, that's going to be everything else. Remember that a whole circle is 360. Right? We've talked about that before. So if a whole circle is 360 and we have 70 here, well, we're going to do 360 minus 70. That's going to be 290 degrees. This is 290 degrees right here. Okay, it's everything that's left over. Okay, so let me write that out in case you forgot. The whole circle is 360 degrees, and that's a key thing to remember for yourself. Okay. Okay, looking at example 3. Right, so it's going to be good to have a couple colors here. We're going to need our colors for this because there's lots of angles. So if I know that this is 100 degrees, okay, let me think about let me just highlight that. And we don't have to go in order by this. I'm just going to see what I see. So that's a central angle, and it opens up to this arc right here. Okay, so the central angle equals the arc that it intercepts. So this one's going to be 100 degrees. Okay, the measure of the angle for arc FH is 100 degrees, and so I'll put that right there. Okay. Okay, let's see what else we can do. Well, I can figure out this angle. This angle, I can see that this 100 plus this angle, they form 180. They form a straight line, so it's 180 they add up to. So that means this must be 80 degrees. Going back to our angles from Unit 3 first semester. Okay, that's 80. Okay, how's it? Well, if I now trace that angle for myself, that angle that opens up to this arc right here, I can see that this is going to be 80. I'm getting using my central angles. So if that's 80, then DH is going to be 80. Okay. Okay, so we have those two, and that makes sense because look, if I look at arc DHF, right? That is half a circle should add up to 180, and it does, right? So there's ways to check yourself. Okay. Let's look at what else from what I marked I can put down here. All right. Let's see. FGD. FGD is this, right here. Here's FGD. Okay. That's half a circle, so that's going to be 180 there. It really does help to use all your colors. Okay. See what other angles it wants me to get. Angle DEH. Oh, well, I already did that. Angle DEH is right here. That was 80. Okay. What about angle DHE? Okay, so now this one's we're gonna have to keep in mind some important concepts we've done before. I want to remind you that all radii are congruent, right? So it might help to put these tick marks here. Okay. Now, take a color, any color, and highlight this triangle right here. Okay, and the note I want to remind you of is that two radii form an isosceles triangle. Okay, look at that. Because the radii are congruent, then this triangle must be isosceles. Okay, it could also be equilateral. That's in certain cases, but it's always going to be isosceles because you always have at least two sides congruent. Well, since those are congruent, these two sides, that means these two angles are congruent. So since we're always going to have isosceles triangles, we're always going to have those two congruent. I can find those two then, because 180 minus 80 is 100, and then they're congruent, so I'll cut it in half. So each of these two is going to be 50 degrees. Okay? So they're each 50 degrees, so we got that one done. Okay. Example 4 is basically the same type. You use the same skills, so you can try that. I want you to try that on your own. Right, complete that, and then upload your work. Okay. Example 5 is more of the same, so I want you to do those and give it a shot. And the second example 5, more of the same, right, with those angles. Okay, and let me just see. Okay, and I just want to see how we're doing here. Yep, all those skills that we've talked about before, so try those. Okay, let's go to this page. Example 7. Okay, example 7 here. Right, we look at it, and if we trace the angle that we have, we can see that angle that we traced, if we connect, that is an inscribed angle, right? And so that arc that's opened up to, okay, that's going to be, remember that inscribed is twice as much, so the measure of the arc is going to be 102, right? Okay, so in this case, right, this is an inscribed angle. And our inscribed angle is always half as much as the arc it opens up to. So that's going to be 102. Okay? Oh, my number's got cut off for this one. I don't know. Let's make up a number. Let's call it 120 degrees. I have no idea what it's supposed to be. Okay? So if we look at this, and so sometimes you have to reverse it, so I'll trace that. Okay? And I see that it opens up here the sides of the angle. So I can see there is my inscribed angle. Okay? We remember that the inscribed angle is half as much as the arc it opens up to, so that's why that's going to be 60 degrees there for myself. Okay. If there are multiple inscribed angles, you just do this a couple times, you trace each one. So if I trace the first one, okay, that inscribed angle of 20 degrees opens up to this arc. So inscribed angles are half as much, so that's going to be 40 degrees. Oh, 40 degrees right there. Okay. If I trace my other inscribed angle, there's my other inscribed angle. My other inscribed angle opens up to this arc right here. Okay. Right. Inscribed angle is half as much as the arc it subtends or it intercepts, so I'm going to cut that in half. That's going to give me 50 degrees. So the measure of angle DAC is 50 degrees. Okay. Last question for this, what's the measure of the angle for arc BAC? Oh, that's everything else. So I have a 40 here and a 100 there. Right? That gives me 140. So 360 minus 40 minus 100. So I'm going to be left with 220 degrees. Okay? So you just need to trace your angles and try each of those problems like that. Okay? Right, if you don't trace your angles, it's going to be really tough to do. Right? So you have to make sure you're really careful with those tracings. Okay? I'm going to keep going with these examples on the next video, but I think I have to stop here for YouTube.